Testing 1, 2, 3. I have no idea how it sounds. Okay. Oh, interesting. Oh, doesn't show the. What in the world? Kind of funkiness. That's weird. What's up, Beeper? There we go. What's up, dude? Okay, so when it starts up, we create a local space. And right now, this is the only space that we can do. So we're going to create this space here. What's up, dude? I have no idea if this is streaming or not. I'm going to see on my phone if this is streaming. I don't know. Can I do that? I don't know. Mail time. It says it's streaming. Yeah. This says it's streaming. Stream health, excellent. I don't know. As far as I can tell, we're streaming. What are these buttons? No. No. Okay. So ibgib, the way this works, or ibgib, well, we'll go through the little welcome page here. That's right. So this prototype humbly flaunts the most hopeful crypto DLT protocol. Note it's not a token. Yeah, so I'm not a token person, but I use it as a way of, well, I recognize it as a way of metering automatic code running, which inevitably we want to be tied in with the code running. You won't just have it run willy-nilly. So it's not about being completely disconnected from the code running. It's about how do you maximize the dynamics of interoperability and a couple other things. So decentralized code. Right now we're very centralized. This app right here, all of the data, when you download this, all of the data is stored in local storage. So using Ionic. So right now, it auto generates some data for you, but it's all stored here. Over here to storage. Right. So it creates a default space, or what I call a zero space. And then that is like a meta space. It always has that name. I put the zeros there. So whatever you name your space, it's going to hopefully come before that, just for ordering purposes. But so you get a default space, and then we created a space testing July, blah, blah, blah. So if we scroll down far enough here, we're going to start into the ibgib testing July 12, blah, blah, blah. So anyway, so it's a distributed, it's for decentralized collaboration, interoperability. Internally, it's very much like Git. In fact, I accidentally, re-implemented a lot of Git's internal object structure. I didn't realize that it was a DAG. When I started on this road, I didn't even know what a DAG was. I didn't know what a graph database was. I didn't know any of that stuff. So I was just trying to solve caching issues, and I thought of what if we could version control both the class hierarchy, the code, as well as the data, and have it live in the same world. And this is the most recent DLT aspect of it. Before that, I was on the event sourcing, not because I loved event sourcing, but because it was already similar to some of the ideas I was talking about with moving away from relational databases. But that was over 20 years ago. Before microservices became a thing, I thought of autonomous services. So all of this is the same architecture working towards what I had called a long time ago autonomous services. But the thing is that I was thinking of it as a plugin architecture. Back then, it was before Silverlight was killed, and before Silverlight. But so the thing with the plugin architecture is what about when you want to have the plugin architecture itself be pluggable? And so, long story short, it comes down to naming things and addressing things. And so it ended up being, how do you execute decentralized distributed programming, where your plugin architecture itself can change, and you should be able to address your plugin architecture and say, well, this one's doing very well, this one's not doing very well. I like this one, I like this one. So thinking of plugins, but talking about the meta plugin architecture itself. So anyway, so this is a DLT protocol for distributed programming. The tokens are one way of deciding which, nowadays they call them smart contracts, but which code you're going to pay attention to. And by pay attention to, you can think of your processing unit as your brain. Which one is it going to attend? Which one is it going to focus on? Let's move on here. The little cheers. There we go. So the protocol apart, it was born apart from other DLTs and blockchains because I didn't say, oh, Bitcoin, how can I use this blockchain thing? How can I extrude this architecture and use it in something else? Like I said, I've been working on distributed computation for, quite some time. And DLTs, the content addressing ended up the strategy that I started using for, how do you name things that you're going to evolve over time to where you can point to the previous thing. And it ended up being very similar to like Git. The one thing in my mind may have been the Git commits. But largely it was just, I realized, I can memoize some data, I can have that data be representative of the code, and then I can start evolving that. And so I needed a way to evolve it. So I started the way of content addressing it. So here, most protocols addressed by just the hash, some with some hard-coded metadata. So in Bitcoin, from my understanding, it's just a hash. They hard-coded the hash. They say the previous block, here's the address, it's this hash. But the only one, I mean, I kept up with a bunch of different architectures, but the only DLT architecture remotely similar that I've found is something called IPFS. Again, I wasn't coming from the IPFS world. I came across them after a while, and I saw that they had something called multi-hash. So they have some hard-coded metadata plus the hash in order to address some node in the DAG, so a node in the graph. But the issue is that it's still hard-coded of what's your schema for the metadata. And for this, before I found IPFS, before any of those, I had that choice of, what do I want to hard code in there? And I wanted to get as little as possible hard coded into this. So I decided just to use the hash for the gib, and then I have just an open metadata, then I have a delimiter. So I chose the caret delimiter, which ended up being same as get. I chose that because I type ibgib both with lowercase and uppercase g's. And so the caret was both a delimiter and also an indicator that the G was uppercase. But I'll get into that later. So, but the point is that what is the thinnest schema you can have? And the thinnest schema is for content addressing. You have a hash, and then you have the metadata related to that hash. So even if there's a hash collision, which there is, depending on your metadata use case, you can have domain data to make it even less likely to have a hash collision. So when you have, like, for instance, if we go into one of these, here's the space. And if we look at the content, or, I think I already have it already, yeah. So, excuse me. We'll do a little vim. Okay. So, like with IPFS, they do not separate the internal data and the external data. They have like a way of indicating whether something is a link or not, which is very interesting. Oops. My route that I had already come up with is to have the ib, the gib. So the ib is the metadata that we're passing along in the address. The gib is the hash of the ib of the entire record except for itself. Data is an intrinsic data map. And the relations are where you have your links to other records, right? So those are your like sort of pointers to other objects, if you want to think of ibgibs as being sort of objects frozen in time, snapshots of objects frozen in time. So here's the relations. And the one we're looking at right now is a space. Here's the relations because it's funny. Other, graph jargon calls them apparently edges or links. But we have named edges. So, for example, with the IPFS, they started off with, they just had links because they were thinking of files and folders. I was never thinking of just files and folders. I had abstracted away, what are these relations between some things? Containment can be one of them. So a file and a folder is a hierarchy with containment. But so I have named relations. And the address are not just the so not just the hash. So what I call a punctiliar hash, or a hash of one data. This is the hash of the data. So if you look at the gib on this object, here's the gib. But we're relating it to, here's how you do configuration inside of the space. So here's the schema of this thingy of the relation is config key meta special latest gib. So this is the temporal or transient index to the latest pointers, kind of like head in Git points to your latest branch. Let me turn off notifications here. Yeah, sure, I can get a job somewhere. Okay. So it's just different things. You can have schemas as needed. So in this case, the meta special latest, that's part of the schema for what I call special ibgibs or meta ibgibs in a space. Those are kind of like your configuration settings. But the address, here are the pieces. This 341127, blah, blah, blah. That's the punctiliar hash. Here's the hash of the, what I call the temporal junction point. It's kind of like the head, the beginning after a fork. So when you have a branch in time, a timeline in Git, if you were to branch that, there are two key relations. One's past, and the other one's ancestor, but this one doesn't have an ancestor. So when you fork something, it adds to the ancestor relationship, and then it clears the past. So anyway, our schema is the punctiliar hash, the temporal junction point, or our stream ID. I've seen recently something for the IPFS world where it's ceramic, yes. But streams have to be a first-class citizen as far as I'm concerned. So, excuse me. So you have the ib metadata, oops, punctiliar hash, stream hash. And that's just a convenience because it ends up being very useful knowing what the stream ID is, because when you go want to look for the most recent, you're inevitably going to just say, look at the first pointer and then slide to the end or reference that. Anyway, so that's how the content addressing works. It's not just a hash, it's a very thin layer. And then per use case, you can decide what metadata you want to include in that. So for example, the IPFS stuff, with the knowing what hash is being communicated to you, that can either be known by context, or if it's useful per use case, then you could include that in the metadata, whatever your way of doing it. So but I mean, they had their decisions, and they're a lot smarter with me on existing architectures. This was solution, the DLT part of it, to cache invalidation and trying to get caching to work correctly, as well as data. So each of the ibgib frames has two relations, the ancestor and the past. So this is inheritance for both the code and the data, plus a granular version control, because internally Git keeps a record of commits, but it's just its uses are at the file level, and it uses diffs to transform between the different files. So it applies diffs, whereas for us, the stuff we apply are these DNA. So we can come back to the welcome screen here. It'll be easier if we just go here. So this was a new account, new space. This is a temporary Firefox profile. But so here's that past. If we go ahead and just, we're inside of a tag, you can add stuff, a comment inside of a tag. So right. So if we go inside of this thing, now our context, that's like going inside of a folder, even though we went inside of a comment. And then there's the ancestor relation. So ancestor, I just have it go from comment gib. So when it has gib, it just means that it's a primitive. So instead of hard coding, what are my primitives, like number or integer or float, again, you can just say that something, you can have metadata associated to data and have your architecture or your specs for whatever your primitives are. You can have that all on chain. So when you go to send data to someone else, kind of like Swagger or whatever, you can also send not just the data, but you can send the projections of the metadata. And of course, for common things, they'll already have them localized. But anyway, so the DNA relationship, if we look at this fork, duplicate the, oops, that's not what I wanted. So I'll paste in, there's the fork address. I don't have it to where you can easily just navigate to it. In this prototype, my previous one I did, but. So here, instead of having a diff, this fork is applied. So it took whatever the source was, which in our case was the primitive comment gib, and it included, what is my destination ib, which is the metadata. So in this case, the schema is comment. It's like an atom in Erlang. Here is test. So that's actually a transformation of the comment text itself, which is useful. It's saying give it a new UUID and a timestamp. That'll give the temporal junction point something unique. So now this comment is going to be unique in the universe. DNA true means you're tracking DNA, which means that we're going to be able to merge timelines like in Git. You can merge when you go and you say merge branch, A into branch B. It takes the diffs that A has that B doesn't have, and it applies those, and it has some checking depending on what's going to happen there. Encounter is a convenience for how many levels or keeping track of mutations, and the type is a fork. So we're forking the fork gib and we're forking the comment gib. This fork itself is an ibgib, and its ancestor is fork gib, which is just a primitive. So the past, if we look at this, duplicate. Oh, now I'm gonna I do all this stuff manually right now. All right. So here's the past. I paused it. If you see n is 0, so that's that n counter in the fork. So this thing had a DNA that forked the comment gib. So that's forked the primitive. This one is the temporal junction point. It applied this fork to the primitive, which basically just says, okay, this data is going to be applied to that stuff. So, we can just so going back to that ancestor and past, multiple inheritance for code and the data. So when I go and transmit from one, what you think of as a node, communicate between two nodes, or I think of it as spaces, I can send the data and the metadata in the same graph. And it does it like synchronization works between two spaces by sort of like a git merge, where it applies those diffs, where it applies this DNA. If you know event sourcing, it's like an aggregate that applies past events. But in event sourcing, you have an aggregate that you want to reproduce deterministically, as deterministically as possible, as purely as possible. But with these, we want the flexibility to be able to apply the DNA to different timelines. And that's how we do this synchronization. It ends up working very much similar to CRDTs, at least one type of CRDT, where you know that two branches are equivalent if they have the same transforms applied to each other, with, depending on how you set it up, it'll be deterministic or not. Okay, so no single source of truth. I'm not trying to keep everything absolute. So inaccurate, intractable, none of these things are true, okay? These things are a record in time that we try our best to have integrity using these cryptographic hashes. But you can always have re-edits. You can have rewrites of history. These are never sources of truth. That's a philosophical difference, I guess. But in this case, you take the dependency graph. So this comment here, this has a dependency graph. Everything in here is in the past. So it's got its past, it's got this comment, but it's all in the past. At any one point in time, you can find the entire dependency graph that built that particular whatever that ibgib was. But you can send slices of that, sort of like streams off of an event source. or projections. So sort of like a materialized view, basically, in the relational world. I'll leave that up. So the whole point is that, you can send beliefs from projections among nodes, and you can configure it on chain to where even your metadata is part of the code. It ends up that, sort of like starting up your computer and the certificate checking, it ends up, you got to be careful on how you set up the initial exchanges, just like we're very careful with certificate authorities and chains of trust and that sort of thing. But here, once you establish that, then you're going to be able to send data and exchange data among spaces, and you'll be able to cut off the past. You'll be able to say, sort of like checkpoints and event sourcing, you're able to say, okay, at this address, we're just going to accept that as good enough. But it's just, and we see Bitcoin and all of the forks and that sort of thing. It's just not going to happen to where it's going to live forever. You may, if it lives forever enough, or with enough integrity for the people that believe in it, then that's good for them. So this is append-only data. In fact, a lot of these I don't even have deletes implemented, although I do for locking purposes. Some of them I create locks just to reuse the data, but that's an implementation detail. But so it's append-only data, but it's always what I call a humble point of view. So I never think that my data is correct. It's a belief. I can, believe in it very strongly up to a certain point, but it's never, its job is not to supplant my beliefs or something like that. It's out of date, it's incomplete, and eventually pieces of it are going to be inaccessible, whether it's from takedowns or corruption or acts of God, multiple points of failure. But we already account for that, because the whole point is to have as biological and living data as possible. I'm going to get some water just real quick. Dude, seriously stuff. Let's go watch this anyway. Not with that attitude. Okay. So again, it's severable data where we're able to take this projection and then we'll say, okay, well, we're just going to clear out the past, clear out the ancestry if we want. We can do whatever we need to in order to sever this or create a new data that just has this inside of its data, not its relations. So in code, what that means is, like, when I check the intrinsic integrity of a graph, anything in data is just a blob. I just, it can be whatever. But the relations, I call those like hard links. These are hard relationships to other pieces in the graph that should exist in my space. If it doesn't, then there's something wrong. But so we can change the we can change them from hard links to soft links and just put them inside of the data. That's how we can implement that in code. So here again, this is just one example of metadata living alongside data, is that you should be able to send an ibgib, a DAG, a dependency graph of data that describes what your consensus algorithm is, or what your consensus requirements are. And basically that's going to be, some number of spaces attest to some address, which again, that's the metadata and the hash, or in the future, it could be multiple hashes. But you can send that data alongside the data itself. Very similar to like when browsers negotiate what they're going to do for, what version of TLS. So it's part of the handshake process. But the point is, the handshake process itself can be on chain, and there's actually an interesting way of communicating to where you can have that transactional. But since I spend all my time working on, getting swiper whatever to work and that sort of thing, I don't get to spend as much time yet on continuing to implement those kinds of things. So, and again, ibgib's not a token. Money, isomorphic to interneuronal weights, is able to be your interspatial attention. So you think of each of these spaces as being a node in a neural network, and you can think of money with people being the entities and businesses being the entities. You go somewhere, you pay them some money. That's representing how much attention they should give to your processing. So they are saying, well, you're giving me money, so I'm going to attend you such and such resources for whatever my business is. But the business can always decide, who does it want to be its customers. Of course, in practice, that's going to be subject to governmental oversight and that sort of thing. But in this case, you're going to have the government oversight be able to see the graph of the exchange. Again, it's never going to be truth, and that has to be included in how we approach these things. You don't want to have a Blake's, what was that show called, Blake 7, to where now you're just giving all control over to some black box algorithm that looks like it's transparent, but when you know the specifics of how they work, totally not transparent. It's just it's more translucent, and that's what we have to understand is using these things as translucent tools. But ibgib empowers both more autonomous crypto-based decisions as well as human-centric ones. So because of the way, again, I haven't implemented on this MVP yet, but because of the way identity works, humans have the same kind of identity as microservices or AIs or businesses, because all of them end up looking like this isomorphism here. A human has the neural network inside their brain, which is doing this weighting, and then interhuman communication. We have money, we have other ways of describing how we attend other people. And then we have, inter microservice communication, inter ML communication, which, by the way, once we have models, AI models working more autonomously, this already gives you the architecture to be able to not only take some AI model, but to both have the AI model, but give them a way of having location and a way of sending that model from space to space. But that's for the future. But anyway, so the point is that once you have this one protocol in place, now you're able to have a federated identity, similar to how the DID is working. In fact, we'll just look at that real quick. So W3C, which I assume they're still going along the RDF triples route, which is it's not enough for me personally. It's about how you compose those triples. In fact, you can think of these as being triples, where you have the node and then the relationship name. So in this case, DNA past, that's the relationship. And then the other end of the node, that's the object. So you got the source, the verb, and then the object. But anyway, so, but they're did syntax. I think I looked at this somewhere else in one of the other videos, but I'll look at it again. Did method name, character, PC percent encoded. Let's see if it has it in just one. Here we go. So they're talking about their schema. Here's their schema. But again, you could have the schema as part of the graph. I know they're still linking the existing Web 2 architecture, but you know, perhaps they have their way of addressing this schema also within the DID or within the W3C URI syntax. But anyway, so here's the IB, the metadata, and then here's their hash, and then there's more metadata. So, but they're hard coding it in whatever this schema is. So, you know, again, that's another, those RDF triples, another pathway. Don't want to get sidetracked on that. All right, so 40. Still going? Yeah. So one more. This prototype. So just a prototype now, we can do some things. The future will do all the things. Offline first notes, picks, and links. So right now we can keep track of notes, picks, and links. Full history audit logs, synchronized to the cloud. In the future, more complex schemas. Right now I don't have it. That's one of the interesting things on Ceramic. I don't have schemas enforceable on chain just yet. I haven't found that personally useful just yet, but yeah, Ceramic's a very interesting library. Files are folders, so you take a picture, you go inside that picture. It's no longer we have a file and a folder is only text, and hierarchy is the only relationship. Now we have a picture of a garden. We can go inside that picture and take a picture of a plant. This is how I actually use it. And now you can track both that picture of the garden and picture of the plant. You can think of those as being two objects that have references to each other, and both of those objects are mutating over time. You can add a comment, add a link. Heck, you can go inside that comment and add another pic. So in the future, though, this is the beginnings of the required plumbing for the metaverse. So anything that already has too much complexity on top of it is not going to scale well. So if they don't have something like this, it's not going to, in my opinion, it's not going to scale well. It's not going to be interoperable. And interoperability that's very key to this. It's very much like how much we've come along with open source software. Well, open source software really enabled a reduction of complexity or a maximization of utility for people who have an issue with code, and they go in, they can fix it and then send back the changes centrally. Of course, it opens up a can of worms with adversarial context, but that's what scale's for. We have too big of libraries, not enough granularity. Git is not granular enough to move forward. But try explaining that to people that use Git every day. Anyway, so this comment, right? Add a picture. We'll add Kentucky Wildcat. There's the picture. Right, so we just added a picture, quote unquote, inside the comment. What that actually did was mutate the comment. We got one more comment in the past array, and we have a pic relation to the pic. So you can see 321F8 with the event stream, the temporal junction point, or whatever they call the stream ID. I call it temporal junction point 40B. So 321F 40B. We go to this thingy here, look at the information. So the that's the hash of the bin hash is 321F. The ibgib, it has the 40B, but the gib itself is, so here, go back. So it's this thing, 2F57 after the delimiter. So before the delimiter is the ib, and just one of the ib in the schema for pictures is the binary hash. But the punctiliar hash starts off 2F57 and ends 53, but the stream, the timeline, as I call them, 40B. So (257), and then the timeline's 405B, and then if you look down here, the timeline or the temporal junction point, here we go, there's the 40B3. So that's the very first node in this graph with this past relation. So notice, so this past, this is a list in a blockchain. This is what you would normally say the blockchain when it points to the previous block. It's very similar to that. In our case, we're pointing to the previous punctiliar point or frame or quantum or whatever of this timeline. So right now, for implementation purposes, there's two choices you can make. One is you can have this be only one relationship, one pointer to the previous one, like a linked list. or in this case, for me, for a small scale, the trade-off is execution time versus storage. So since storage is relatively cheap and these are relatively small graphs, right now, especially for a pick or a comment, I accrue all of the past. So each frame grows by another link, another content address here, plus the address of all of the DNA. But yeah, so we added a picture inside of a comment. Now we're inside that picture. We can look in here. Here's the picture full screen. Something I did recently, screwed up the thumbnail, but inside of a picture, we can add another picture. We'll add an old screenshot of this prototype. There we go. Oh, we'll add another one. We could have selected more. All right. So this isn't sending to anybody like off in the world. This is just dealing with our local space. And in our local space, our offline first space, we added a picture inside of another picture. So now we have this picture with multiple picks in the pick relation. And we added another couple entries in the past relation. Because each time we mutate, we add one to the past, whether we mutate intrinsically, meaning inside this data field, or we mutate this record extrinsically by adding or removing a named link. Again, notice the DNA. So if we were to take these DNA and apply them elsewhere, it's going to say, oh, it's going to have the relate. So here, we'll go look at this relate. And then I'll go into the spaces a little bit. Although we're right at an hour. But well, still. Because it's fun. So inside of the Kentucky windshield picture, ibgib, not the binary itself, but the ibgib, it had this relation in its DNA. And so we're going to look at this DNA. And what it said is that when we made that picture, when we added a picture, it created a binary ibgib. So here's the bin, the atom. Our schema is bin hash, and then extension, which in this case is JPEG. We're keeping track of the DNA. We're keeping track of the counter. So the thing we did, the DNA, the transform that we did was we had relations to add by address for relate, and then we added this. And so that is like our diff. That is like saying we are adding lines 4 through 10 or whatever in the source code to some file. But in our case, our diff is this DNA, and this is effectively what we're applying to whatever our source was, whatever our source ibgib was. And so what this thing did was It went to the previous, so this is the ibgib record, right? This whole thing is the raw data for the ibgib record. It went to a previous one that looked very similar, only it took whatever it was, and then it added in the bin relation, it added this address. So we go back over here, we're going to see the effect of that. In the bin relation, it added that address, FAAB51. FAAB51 right there. So that's the transform that we did. That's the relate transform, which rate 0950. So this relate. So if we go back to the original fork and we find the original source and we apply this fork, we apply this mutate, and apply this one, this one, this one, we're going to end up with something very similar to the current state insofar as this is the state, the relations and this internal data. Now the timestamp is going to be different, and maybe the original fork is going to have a different UID. So you got to take that kind of stuff into account and whatever the use case is. But the point I'm trying to make is that instead of a text-based hyper-optimized Git, right? So Git is for files. It looks inside the files and it says, what are the text lines that have changed? I know now they have blob tracking, and it's probably very efficient for what they're talking about, but it was an ad hoc thing. They added it on for functionality, and there are consequences of that. But this, from the very beginning, what we're talking about is not text-based file granularity. We're talking about concept level granularity. We can have files as our objects. In fact, I have in the previous prototype, I did implement a version control, a very rudimentary version control system that's able to, spit out files very similar to how Git, when you say like, check out a certain branch, and then it looks inside of its internal database, and then it applies or it outputs whatever those files are. You can have that at that level, but you're not required to. You can have this at the function level. You can have this at the data level. You don't need to just think in terms of files and folders, and certainly not text files and diffs of text files. So these are the transforms. These are our diffs, but it's at the semantic level, and it lives alongside the other data in the cryptographic tree. I think you could call it a hypertree because it's always growing. But I heard in the IPFS dude, Juan Bennett, saying a Merkle forest. So whatever you want to call it, the point is that your data lives alongside your other data, and in this case, our data for transforms live alongside the data that they are working on, that they are transforming. And that gives us an extremely powerful way of doing Git-like operations, but not restricted to text. So besides IPFS, the closest DLT technology to this technology that I know of is Git itself. So anyway, that's over an hour. I was going to go through the spaces, which is what I'm working on right now. I'll show it real quick. Nobody's watching this anyway. Oh, we were going through this. One more thing. Okay. And then I'll look at the spaces. crappy cloud adapter built with user-owned DynamoDB as 3 prayers, hopes, and dreams and duct tape. In the future, we'll have self-configuring, self-healing, ad hoc replication architectures. It's actually more like composable than that. So we'll be able to do cluster style architecture, but again, have the data and the metadata live, have it be able to bootstrap itself. Very similar also to how Docker works. Robots, we already have a very rudimentary chatbot in place. So I have some architecture in place in order to instantiate robots. So if we go over here, look, we'll go over here to the robot. For some reason, it's not responding. Weird. Never seen that before. Maybe that's something to do with the streaming. So we don't have a robot right now. We'll add a robot. All I have is a random robot. And so the way that this works, just real quick, I'll call him Randy. And so basically the way it works is that now, so robots right now, robot with double B's because of Robbie the robot and the Asimov robots. But so the way Randy works is that right now, this is our context, right? When we look at this raw Kentucky windshield, this is not this picture down here, this picture down here. Our context, which is what this bar is looking at, is this picture and the associated ibgib. So we're just going to say, Randy, take a look at this. Randy's got it. We'll go inside this picture. It remembers which robot we have selected. We say, Randy, look at this. Okay, got it. And then now, if we were to go, let's just we'll go inside this comment here. For some reason, it's not showing that automatically. So instead of looking at something, we can have this one in Randy's case, because it's the very first quote unquote trivial example or a very simple case. When you say Randy talk, he takes one of his things that he's seen and he says it. And so now this is actually an ibgib, just like if we had imported that ibgib. So we can actually click on it. Now we're back to this thing because this is what Randy was looking at. Of course, that you may notice that has that's given us a what's the word? Self-referencing structure. In the graph, it's actually not self-referencing because it's a DAG. It always looks in the past, but because of our unique past relationship, as far as timelines go, it is self-referencing. But anyway, so you can say something. Oh, he's seen that one. Oh, he's seen this one. And I have it coded right now to where Randy doesn't. Once he's said everything that he's seen, he doesn't say anymore. But so if we navigate to the robot itself, just like everything else, is an ibgib. So here's its internal data that we set it up with. And then when you say, look at this, it just puts it under the X relationship. And these are the things that it's seen. So we can look here. I don't have it showing what the relationships are in this list view that I'm scrolling up and down. But inside of Randy, the robot, this is in the X relation. here's what he's seen. So very, very basic chatbots. And that's a long time in coming for that kind of autonomous service chatbot type architecture that's required for that. But so in the very near future, I'm going to be having a slightly more complex robot for learning things. So one of the things that one of the driving cases for me personally is foreign languages. So a long time ago, I came across SuperMemo for what they call the forgetting curve, and they're kind of optimized learning algorithms. And that has evolved into this architecture. But so the next robot will be, you paste in. So you should be able to learn foreign languages not from going to class, or you should be able to learn anything, not from just going to class, but with a kind of like teachers, not teachers, but sort of self-learning. So the robots are, I guess you could think of it pejoratively as like a fancy flashcard system, but it's not just a fancy flashcard system. It's the flashcard system combined with the entire ibgib architecture. But anyway, so for learning foreign languages is how I already use it personally. And the next robot is going to be just slightly more complex. But again, because Randy is itself an ibgib, we'll be able to send this robot, this chatbot, when it learns things. So this thing now has learned, you can think of it as learned, put it in its own memory, these two links to these two ibgib. So now we'll be able to send Randy to another space. So he will be as mobile as the data itself. And it all uses the same architecture. I just can't stress that enough about how that simplifies so many things for what people call the Web3 architecture. So basic chatbots. That's it. That's it for the welcome screen. Geez, it's been an hour and 20 minutes. What the hell? We'll go ahead and go to the Bootstrap. One more thing. Here's how the Bootstrap works. So this is the raw Bootstrap. So Bootstrap, as you can see, is gib, is not, there's no integrity guarantees with this. This is kind of like your git config, which is outside of the DAG. But in this case, it still uses it. It's just it uses that paradigm or that pattern of a primitive or an unguaranteed datum of just having the gib non-hash. But so when this thing starts up, it looks for the Bootstrap. It says, okay, I found a Bootstrap. It validates, what it expects to see here. It has a default space ID. It has the space ID here. And then here in the relations, the relation name is the space ID. And then interestingly, notice here, the link that it sends it to, the space ID is in the link. So that's because in our metadata, we decided for the schema for a space object, or I decided, it's a witness, which is like a ibgib with behavior. It's a space witness. The class name is ionic space because that's the substrate that it uses. Here's the name of the space. And then here's the space ID, which is a random UUID that's generated when the space is generated. So when we made the testing July 12th, It generated UUID. It created this whole thing as the ib. And then it took that data and then gave it a gib. It created a whole record for it. We'll look at that in just a minute. But the main thing is this bootstrap, though, here's where it knows of these spaces. And so what I've been working on recently is, so here's the default space, local space. So we can add a space. Right? So we just added a space. It refreshed. Now our space IDs, it has this other one. When you look at this other one, 23, 23. Here's the name we just typed in. There's that space ID. So now we have two spaces. So if we decide to select that one as our default space, this will select it and it will have to restart or refresh the whole page. So if you notice, it just generated some new tags. The raw, it has a default space ID now. But now if we go to home, I don't remember where this thing was, if it was on, yeah, it was on home. Actually, if we go back now, it's not gonna be able to find it because the space that it's using doesn't exist anymore. So on home, so it's just an annoying bug with a billion things to work on. Just like most open source, too much to do or little bugs. But so now inside the home context, we have this comment here in this space. But if we go back to the bootstrap, we're going to set this back to our original one. It'll restart. This one that couldn't find it before, now it's going to be able to find it. And now when we go home, it's going to have that initial comment. So that's because that's our local space. So, and again, this is what I'm just working on right now is adding, importing spaces. I'm definitely afraid of if I change, how something on this bootstrap, and my app that I use on my phone, which I know is alpha data, I don't really want to lose that data. So even though it's alpha, I don't want to lose it. So, but so this gives me a mechanism. I'm working on a mechanism to, import the data. So since all of this is decentralized, when I'm doing it on the web, this lives inside IndexedDB, as I think I already pointed out. So this is like a custom, just thrown together Explorer that just shows you folders. And once you go inside, say the default space, and we go into the meta, that's where the spaces are stored. That's going to show me the bootstrap JSON. So if we had another bootstrap that was, orphaned or something, we'd be able to go to that and import one of those spaces. So, but right now that's not inputted. So those are local spaces. And since, going on forever here, it's still Still going, hour and 20 minutes. What the hell? So I have no outer spaces. The way that I have that right now, where you can do that. By the way, you can add tags and tag things. So if we were inside here, say we'll go back to the Kentucky picture. That's not actually adding a heart, the favorite. That's, we'll just see that for the fun of it. It's just a little SVG fun. If we tag, and we can create a new tag, or we just do the favorites tag. Now, if we go here, it'll say, hey, that's where we just were. But so if we were to, here's an auto synchronization for the space. I use these little sparkles, ionic icon or ionicon for auto syncing. Here's the rocket to just do a single push sync, push pull sync. We'll just do this real quick. So this is like we're creating a secret, which is like it's just sort of metadata to remember the password. So it's got, the only requirement I have is it has to be at least 8. So, and they obviously they have to do it. So they have to match. In fact, if we don't have that, let's see. So hint, so this is public. So the idea here is if you use a password manager, now that password manager owns your existence. I don't know who thinks that that's a good idea, but you can use metadata to help you remember, help you organize what are your passwords for what sites. So if we said create secret now, password confirms required, also the passwords don't match. But so here you'd add your metadata for whatever your system of doing passwords is. It's just a cue to help your brain remember, oh, okay, well, I forgot with this one I use, hoogly boogly for the context, for my username and password, whatever. But right now we have passwords. In the future, you'll have other secret types. So you create at least one secret. Here's an encryption setting. So I made my own encryption. I know it's evil to do that, but that's the only one I have right now. I did a bunch of whatever. We're just gonna change it to. So these are details of the parameters of the ibgib encryption that I made. Again, I'll make another video about it, which I tried to do the other day, but I just not very good at these videos because the big news was NIST announced the post-quantum accepted candidates, and one of them was Sphinx Plus, which I've looked at for several years now, because Sphinx Plus uses a hypertree, and that's also very similar, although they're super hyper optimized for size and speed and that sort of thing. But I am not worried about those kind of optimizations at the moment. But anyway, I will point out ibgib uses hashing for encryption, not for signatures. It's my own algorithm. I try finding out if anybody else uses it. They don't, as far as I can tell. Anyway, I'm not going to do this next step, but because I'm running out of juice here. But you'd say blah, blah, blah. Associate your secret. And so here's my crappy adapter that I mentioned earlier. You have to make a DynamoDB table, and you tell it the table name. It has to have this as the key name. You have to have a bucket for the large objects, because DynamoDB has a 400 kilobyte max per index or something like that, which is ridiculously small, but there's very good reasons for that. And then you put in your API stuff, and then what it does is we just used, it encrypts this data only. It doesn't encrypt your data, but it encrypts this data only and stores an encrypted ibgib, an enciphered ibgib that you go and encrypt when you want to go synchronize to your synchronization space. All right, but we'll do that later. I need some food. Anyway, so there we go. I think this has been falling this whole time here. All right. So there's a run through of the welcome screen and some basic functionality. Yeah. If you're watching this and you've gotten this far, dear Lord, let me know. That's hilarious. It's great. All right. So, here, I'll go ahead and just so you can see what that. So here, encryptgib, if you want to look up that encryption, it uses the hashing for encryption, not for signatures, but actual encryption. Here's what the crappy encrypted ciphertext looks like right here. So that is just an example of encrypting. What the basics is, it converts your data to hex, and now because it's hex, you can use hashes as alphabets, as your alphabet, and then you expand your alphabet. You record the indices of your hex characters into the alphabets, and it's very neat, very similar to very strong one-time alphabet approaches, blah, blah, blah. Okay, that's it. I'm out of here. Thanks for watching. If you are, hit me up. Okay, you can also hit me up on GitHub. Just remember though, GitHub's off-chain. Anyway, okay, thanks for watching.